Okay, so we've learned how to graph lines that are listed in slope-intercept form for us. We just plot the b, use the rise over run to get the other points, no problem, connect the dots. What happens when it resists slope-intercept form? Right, this is y equals mx plus b, slope-intercept form. That does not look like y equals mx plus b, and that certainly doesn't look like y equals mx plus b either. Well, these are two special cases that represent both horizontal and vertical lines. So, really, x equals 3 is just talking about how the x coordinates for all the dots that we can create are actually 3. So, if you recall, plotted points, those, yeah, on the xy plane, they're basically x comma y, right? If somebody says plot the point 3, 6, yeah, you would go right 3 units for the x, because x-axis, x, over 3, then up 1, 2, 3, 4, 5, 6. And then you'd plot a point. Well, when you read an equation that's given to you like this, it's saying that the x-coordinate is always 3. The x-coordinate's always 3. So 3, 6 would be a point on the line x equals 3. So would 3, 1. So would 3, negative 2. So would 3, 5. 3, 4. Basically, every single point on this vertical line gives you x equals 3. So, x equals 3 is a straight up and down vertical line. And that's it. There is no y-intercept. It's not there. There is no y-intercept. It crosses the x-axis at 3, which makes sense, x equals 3, but it doesn't cross the y-axis. And what's the slope of this? Does it have a rise over run? No, there's really no way to describe this. In fact, it's an undefined number. So if you're ever talking about a vertical line, it has undefined slope. And again, I can talk more about that in class. Yeah, so what happens if it's the opposite? Let's say that we're not plotting a bunch of points where the x value is giving us. We're given the y values. So think of 5, negative 2, right? X, y equals negative 2. 5, negative 2, it'd be a point there. Or really any value where the y is negative 2. Y is negative 2. Y is negative 2. Y is negative 2. It's a horizontal line when it's just y equals a number. Where this is the y-axis and this is the x-axis. So that's kind of tricky, yeah? It does cross the y-axis, though, at negative 2. And when we talk about slope, there is no slope, right? Remember, think of skiing. It's like, slope. There's no slope here. But also, you got to think about it as 0 slope. So the actual number 0 can be used to describe the slope of a horizontal line. So this is kind of a tricky area. I'm just going to say m equals 0, which is the same as saying no slope. Okay, those are your two special cases that tend to give people, just a little bit of difficulty. You might have to commit some of that to memory if it's not making 100% sense, but again, you can ask questions in person. Last part of this is kind of like a working backwards type situation. Where we are given the line, and I'm asking you guys, can you give me the equation to the line using your knowledge of y equals mx plus b for your regular lines, or using the special cases, right? We know special case would be x equals some number, right? Like, or y equals just some number. And that's how you would write the equation of the line. So our answer should look like this, or potentially these two things. So let's dig into it. Number 8. So we're given this line right here. Our first thing that we should be looking for is what the b value is. Where does this thing start? Well, it starts on the y-axis. Don't think of that as the starting point. Think of the place where it crosses the y-axis as the starting point. It's 1 unit above the origin. So right away, when we're writing this equation down here for y equals mx plus b, it's going to be y equals mx plus 1, because it's 1 unit plotted above the x-axis. But we need to do better than just an m right here. M represents the rise over run. So to get from our starting point to another point, we have to go up 1 unit, right 1, 2, 3, 4 units? Yeah. So up 1, right 4. That's 1/4 for our slope. And you're done. Check out number 9. Number 9 goes right through the origin. So our starting point on that guy is y equals, we don't know the mx, plus 0. 0. And then going from 0 to the next point would be up 1, 2, 3, 4, right 1. So up 4, right 1. That'd be 4 over 1. So I'm going to erase my m and put 4 over 1 in its place. By the way, another way to represent that would just be y equals 4x. That seems a little simpler, you know what I mean? Like, this is more informative. It tells us what's going on, but for y equals 4x, there's just something nice about that. All right, last two. Why don't you guys pause it, try these two on your own, and then let's just see if we match up on the final answer. Okay. All right, you gave it a try. Here's what it is. It starts 3 units below. 1, 2, 3. So that would be negative 3. Y equals mx minus 3. Okay? The rate of change, the slope, is up 1, 2, 3. Left 1, 2, 3, 4, 5. So you would say y equals a slope of 3 over negative 5. Rise 3, run negative 5. I'm just going to call it negative 3/5. And then make sure you put an x because it's y equals mx plus b. There we go. That was kind of tricky. See what you did, see what my final answer is, and just try to adjust. All right, last one, special case. We don't use y equals mx plus b on the special cases. We use either x equals some number or y equals some number. X for vertical, y for horizontal. It's not a horizontal line, so we don't use the y equals. It's going to be x equals just the place where all the x's are living, the place where it crosses the x-axis. So if you go left 1, 2, 3, 4, 5, 6, you're on that line. Left 6. All right. Hey, thanks so much for your patience, guys. I know it takes a lot to go through 2 whole videos for 1 lesson in math, but I think if you watch these all the way through and reference them as we get closer to quizzes and tests, you'll do well with this stuff. All right. Thanks for watching.